Today we are going to start a new chapter, Mechanical Properties of Solids. You know what is meant by solid. Solid is having a definite shape and definite volume, and the particles are closely packed. What about liquid? Liquid is having specific volume but no definite shape. It will take the shape of the container. The molecules are loosely packed. Now what about gases? Gases does not have specific volume or specific shape. They will spread in the entire volume throughout. So the molecules are widely separated. So in this chapter we are going to deal with properties of solids. So chapter 9, Mechanical Properties of Solids. Now solids have definite shape. As I told, solids have definite shape. Some solids are rigid. Some solids are not as rigid. Example, sponge is a solid, but I can squeeze it, and then when I release my hand, it will come back to the original position. You think about rubber ball. I can squeeze the rubber ball, but when I release my hand, it will come back to the original position. Rubber band, stretch the rubber band, release it, it comes back to the original position. So those objects, there are certain objects like that. But think about another kind of object, clay. You take clay, mix it, make any mold it into any shape. Will it come back to the original shape again? No. So there are some objects which comes back to the original position. There are some objects which cannot come back to the original position. So depending upon that, the solids are classified into two. So the mechanical properties of solids describe the characteristics such as their strength and resistance to deformation. Their strength and resistance to deformation. Deformation means changing the shape. So I am here I am taking a phone and trying to bend it. It cannot be bent easily. But if I am taking any stick, a small stick, and trying to bend, it will bend very fast. So the stick is having less resistance to deformation. This phone is having more resistance to deformation. It describes about the ability of an object to withstand the stress applied to that object. The object also resists the change their shape. Example, so I have just given the figure, clay. Clay is looking like this. I am mixing it with water, and then I am molding it into a pot. And after molding like this, will this clay go back to this shape again? Never. Such kind of bodies which cannot go back to their original shape after the deformation, they are called plastic bodies. Plastic. But there are some bodies which can come back to the original shape. That bodies are called elastic bodies. So what is meant by elasticity? Elasticity is a property by virtue of which the original shape is regained by the body after the deforming force is released or after the deforming force is removed. The external force which causes the deformation of the body is called deforming force. So this means it tells us how much elastic a body is. Example, a spring. If we stretch a spring or if we stretch a rubber band, it changes its shape, and when the external force is removed, it will come back to the original position. So such kind of bodies are called elastic bodies. You know, spring is made up of steel, so steel is highly elastic. Steel is much more elastic than rubber. That is why we are not using rubber for making the spring. Instead, we are using steel for making spring, because steel is more elastic than rubber. Now, what is meant by plasticity? Plasticity means it is the reverse of elasticity. That means it is the property which means a permanent deformation. Permanent deformation. The body will not come back to the original position. The object never regained the original shape even when the external force is removed. These types of objects are called plastics. I don't mean plastic means the plastic that we use. I don't mean that. See, this pen is made up of plastic, but I can bend this pen, it will come back to the original position. See, I am taking its refill. This is made up of plastic, but I am bending it. It is getting bent, but when I remove the force, it is coming back to the original position. When I give the deforming force, it is bending. When I remove the force, it is coming back to the original position. So, even though this is a plastic, this body is an example for elastic body. So, what I mean is, plastic is not plastic, plastic is elastic. Okay. So, this material is made up of plastic, but this is having the property of elasticity. That is what I mean. Okay. Yeah. See, toys, buckets made up of plastic, toys made up of plastic. Those all things, once we change the shape, it will not come back to the original shape. It cannot have the ability to regain its original shape. Now, what is meant by stress? Stress is something related to pressure only, because I have written it is the force per unit area. But what is the difference between stress and pressure? Pressure is the normal force acting per unit area, which means if this is the surface, I have to act the force perpendicular to the surface. Perpendicular, this is called normal. I have to act the force perpendicular to the surface. That normal force per unit area is called pressure. And what is stress? It is the restoring force per unit area. So, equation is same. Equation is stress is equal to F by A itself. Pressure is also equal to F by A. But this is the restoring force per unit area, whereas pressure is normal force per unit area. So, whenever we apply an external force on the body to change its shape, there is a restoring force that develops in the body in the opposite direction. So, what is meant by restoring force? It is the force which makes the body to come back to its original position. That force is called restoring force. So, restoring force is always opposite to the direction of the applied force. That is what I have written in this statement. For example, when we apply an external force to a rubber ball, it changes the shape. And there is a restoring force which acts in the opposite direction. This opposite force is known as restoring force, and both the forces are equal in magnitude. So, when I release my deforming force, due to the restoring force, the rubber ball comes back to the original shape. So, as I told you, stress is equal to force by area itself by equation, where F is the restoring force develops in the body because of the force that we apply. The applied force is called deforming force, and the force which takes place inside the body is called restoring force. SI unit, Newton per meter square or Pascal, and the dimensional formula is mL raised to minus 1 T raised to minus 2. Now, there are three types of stress: First one is called longitudinal stress, second one is called volumetric stress, and third one is called shearing stress. So there are 3 types of stress. So let us come to longitudinal stress. What is meant by longitudinal stress? See, for example, here I have taken a cylindrical rod, cylindrical wire, and I am pulling the wire from both sides. That is what is given in the second figure. I am giving a force on both sides. So when I give the force, what happened? The length of the wire is increased. So initial length is L and the final length is delta L. So when I extend the wire, when I pull the wire from both sides, the length of the wire increases. So there is a restoring force which acts in the opposite direction, which tries to bring the wire back to the original position. That restoring force per unit area is called longitudinal stress. So longitudinal stress is the restoring force per unit area when the force is applied to the cross sectional area of the cylindrical body. Cylindrical body means just imagine a wire, that is it. Wire is an example for a cylinder. So as there is change in the length, therefore this type of stress is called longitudinal stress. Now longitudinal stress can be classified into 2: tensile stress and compressive stress. Tensile stress means I am pulling the wire from both sides. When I pull the wire like this, its length will increase. So if the length is increasing, then that stress is called tensile stress. Now what is meant by compressive stress? Compressive stress means I am just pushing from both the sides. That is the figure given here. I am pushing it from both the sides. So when I push it, what happens to the length? The length will decrease. If the length is decreasing, such kind of stress is called compressive stress. Equation again remains same. Stress is equal to F by A, force by area. But the different terms are used just to show. Tensile, that is to increase the length, and compressive stress means stress causes a decrease in the length. Now the second stress, the second type of stress is hydraulic stress or volumetric stress. In hydraulic stress or volumetric stress, you can just look at the figure. Imagine a ball. I am just immersing the ball in water. So water will exert pressure on the ball from all sides. So imagine ball is not so hard, the ball is soft. So because of water pressure, what will happen? Since the ball is very soft, the ball will be squeezed. So there is a change in the volume. Okay? So here I am telling pressure. You just see the arrows that I have put in all the directions. Those arrows are perpendicular to the surface, no? So the force that I am applying is perpendicular force. Perpendicular force by area is called pressure. So that is why I am using the word pressure. So I am applying pressure from all sides. That means when the ball is immersed in water, the water is applying pressure from all the sides. As a result, the volume of the ball will decrease. The ball will be squeezed, so its volume will decrease, but the shape remains unchanged. There is no change in the shape of the body, but there is change in the volume of the body. Then the normal force applied per unit area is called volumetric stress or hydraulic stress. Okay? So because you can see, we have just explained the example, and just see the last line. Because of the force exerted by the water, there is a restoring force which develops in the ball, which is equal to the magnitude of the force applied by the water. So restoring force is always opposite to the magnitude of the applied force, and it is in the opposite direction. This type of stress is called hydraulic stress. So hydraulic stress is normal force, normal restoring force by area, which is same as pressure. Now the third one is tangential stress or shearing stress. What is meant by shearing? Shearing means just turning, just changing the shape. Okay, so here we are applying a tangential force. In shearing stress, we are applying a tangential force. Look at the figure. I have just kept a cube here. Imagine this cube is made up of rubber. And I fix the bottom part of the cube. And I am applying a tangential force. Tangential force means like this, along the direction of the body. That is tangential force. Normal force means perpendicular to the surface of the body. Okay? The force applied perpendicular to the surface is called normal force, and force applied tangential to the surface is called, along the surface is called tangential force. So when I apply the tangential force from the topmost point, I told bottommost point is fixed. So you can see the rubber block is just appearing standing. That means there is a change in the shape. There is a change in the shape, but the volume is not changing. So consider like this. I keep my book like this, and I am just turning the paper by applying the tangential force. When I apply the tangential force, the book is getting bent. Okay, the force that I am applying is tangential force. The book is getting bent, but the volume is not changing. And when I release the force, the book comes back to the original position. Such kind of force is called tangential force, and that restoring force per unit area is called shearing stress or tangential stress. So hydraulic means there is a change in volume without changing the shape, whereas shearing stress or tangential stress means there is a change in the shape without changing the volume. Then tangential force per unit area is called tangential stress or shearing stress. Okay, so those are the different types of stress. That's all for today. Thank you.